Chapter 3, Part 2 of Agriculture for Beginners. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. Agriculture for Beginners by Charles William Burkett. Chapter 3, Part 2, The Plant. Section 18, Plant Seeding. In propagating by seed, as in reproducing by buds, we select a portion of the parent plant, for a seed is surely a part of the parent plant, and place it in the ground. There is, however, one great difference between a seed and a bud. The bud is really a piece of the parent plant, but a piece of one plant only, while a seed comes from the parts of two plants. You will understand this fully if you read carefully sections 14 to 16. Since the seed is made of two plants, the plant that springs from a seed is much more likely to differ from its mother plant, that is, from the plant that produces the seed, than is a plant produced merely by buds. In some cases plants come true to seed very accurately, in others they vary greatly. For example, when we plant the seed of wheat, turnips, rye, onions, tomatoes, tobacco, or cotton, we get plants that are in most respects like the parent plant. On the other hand, the seed of a Crawford peach or a Baldwin apple or Bartlett pear will not produce plants like its parent, but will rather resemble its wild forefathers. These seedlings, thus taking after their ancestors, are always far inferior to our present cultivated forms. In such cases, seeding is not practicable, and we must resort to bud propagation of one sort or another. While in a few plants, like those just mentioned, the seed does not come true, most plants, for example, cotton, tobacco, and others, do come true. When we plant king cotton, we may expect to raise king cotton. There will be, however, as everyone knows, some or even considerable variation in the field. Some plants, even in exactly the same soil, will be better than the average, and some will be poorer. Now we see this variation in the plants of our field, and we believe that a plant will be in the main like its parent. What should we learn from this? Surely that if we wish to produce sturdy, healthy, productive plants, we must go into our fields and pick out just such plants to secure seed from as we wish to produce another year. If we wait until the seed is separated from the plant that produced it before we select our cotton seed, we shall be planting seed from poor as well as from good plants, and must be content with a crop of just such stock as we have planted. By selecting seed from the most productive plants in the field, and by repeating the selection each year, you can continually improve the breed of the plant you are raising. In selecting seed for cotton, you may follow the plan suggested below for wheat. The difference that you see between the wild and the cultivated chrysanthemums, and between the samples of asparagus showed in figures 49 and 50, was brought about by just such continuous seed selection from the kind of plant wanted. By the careful selection of seed from the longest flax plants, the increase in length shown in the accompanying figure was gained. The selection of seed from those plants bearing the most seed, regardless of the height of the plant, has produced flax like that to the right in the illustration. These two kinds of flax are from the same parent stock, but slight differences have been emphasized by continued seed selection until we now have really two varieties of flax, one a heavy seed bearer, the other producing a long fiber. You can in a similar way improve your cotton or any other seed crop. Sugar beets have been made by seed selection to produce about double the percentage of sugar that they did a few years ago. Preparing and tilling land costs too much in money and work to allow the land to be planted with poor seed. When you are trying by seed selection to increase the yield of cotton, there are two principles that should be borne in mind. First, seed should be chosen only from plants that bear many well-filled bolls of long stable cotton. Second, seed should be taken from no plant that does not by its healthy condition show hardiness in resisting disease and drought. The plan of choosing seeds from selected plants may be applied to wheat, but it would of course be too time-consuming to select enough single wheat plants to furnish all the seed wheat for the next year. In this case, adopt the following plan. In Figure 52, let A represent the total size of your wheat field, and let B represent a plat large enough to furnish seed for the whole field. At harvest time, go into section A and select the best plants you can find. Pick the heads of these and thresh them by hand. The seed so obtained must be carefully saved for your next sowing. In the fall, sow these selected seeds in area B. This area should produce the best wheat. At the next harvest, cull not from the whole field, but from the finest plants of plat B, and again save these as seed for plat B. Use the unculled seed from plat B to sow your crop. By following this plan continuously, you will every year have seed from several generations of choice plants, and each year you will improve your seed. It is of course advisable to move your seed plat B every year or two. For the new plat, select land that has recently been planted in legumes. Always give this plat unwearying care. In the selection of plants from which to get seed, you must know what kind of plants are really the best seed plants. First, you must not regard single heads or grains, but must select seed from the most perfect plant, looking at the plant as a whole and not at any single part of it. A first consideration is yield. Select the plants that yield best and are at the same time resistant to drought, resistant to rust and to winter, early to ripen, plump of grain, and non-shattering. What a fine thing it would be to find even one plant free from rust in the midst of a rusted field. It would mean a rust-resistant plant. Its offspring also would probably be rust-resistant. If you should ever find such a plant, be sure to save its seed and plant it in a plat by itself. The next year again save seed from those plants least rusted. Possibly you can develop a rust-proof race of wheat. Keep your eyes open. In England, the average yield of wheat is 30 bushels an acre. In the United States, it is less than 15 bushels. In some states, the yield is even less than 9 bushels an acre. Let us select our seed with care as the English people do, and then we can increase our yield. By careful seed selection, a plant breeder in Minnesota increased the yield of his wheat by 1/4. Think what it would mean if 25% were added to the world's supply of wheat at comparatively no cost. That is, at the mere cost of careful seed selection. This would mean an addition to the world's income of about $500 million each year. The United States would get about 1/5 of this profit. It often happens that a single plant in a crop of corn, cotton, or wheat will be far superior to all others in the field. Such a plant deserves special care. Do not use it merely as a seed plant, but carefully plant its seeds apart and tend carefully. The following season select the best of its offspring as favorites again. Repeat this selection and culture for several years until you fix the variety. This is the way new varieties are originated from plants propagated by seed. In 1862, Mr. Abraham Fultz of Pennsylvania, while passing through a field of bearded wheat, found 3 heads of beardless or bald wheat. These he sowed by themselves that year, and as they turned out specially productive, he continued to sow this new variety. Soon he had enough seed to distribute over the country. It became known as the Fultz wheat, and is today one of the best varieties in the United States and in a number of foreign countries. Think how many bushels of wheat have been added to the world's annual supply by a few moments of intelligent observation and action on the part of this one man. He saw his opportunity and used it. How many similar opportunities do you think are lost? How much does your state or country lose thereby? Exercise. Select 100 seeds from a good and 100 from a poor plant of the same variety. Sow them in 2 plats far enough apart to avoid cross-pollination, yet try to have soil conditions about the same. Give each the same care and compare the yield. Try this with corn, cotton, and wheat. Select seeds from the best plant in your good plat and from the poorest in your poor plat, and repeat the experiment. This will require but a few feet of ground, and the good plat will pay for itself in yield, while the poor plat will more than pay in the lesson that it will teach you. Write to the Department of Agriculture, Washington, D.C., and to your state experiment station for bulletins concerning seed selection and methods of plant improvement. Section 19. Selecting seed corn. If a farmer would raise good crops, he must, as already stated, select good seed. Many of the farmer's disappointments in the quantity and quality of his crops Disappointments often thought to come from other causes are the result of planting poor seed. Seeds not fully ripened, if they grow at all, produce imperfect plants. Good seed, therefore, is the first thing necessary for a good crop. The seed of perfect plants only should be saved. By wise and persistent selection, made in the field before the crop is fully matured, corn can be improved in size and made to mature earlier. Gather ears only from the most productive plants and save only the largest and best kernels. You have no doubt seen the common American blackbirds that usually migrate and feed in such large numbers. They all look alike in every way. Now, has it ever occurred to you to ask why all blackbirds are black? The blackbirds are black simply because their parents are black. Now, in the same way that young blackbirds resemble their parents, corn will resemble its parent stalk. How many ears of corn do you find on a stalk? 1, 2, sometimes 3 or 4. You find 2 ears of corn on a stalk because it is the nature of that particular stalk to produce 2 ears. In the same way, the nature of some stalks is to produce but 1 ear, while it is the nature of others to produce 2 or more. This resemblance of offspring to parent is known to scientists as heredity, or as like producing like. Some southern corn breeders take advantage of this law to improve their corn crop. If a stalk can be made to produce 2 ears of corn just as large as the single ear that most stalks bear, we shall get twice as much corn from a field in which the 2-eared variety is planted. In the north and west, the best varieties of corn have been selected to make but 1 ear to the stalk. It is generally believed that this is the best practice for the shorter growing season of the colder states. These facts ought to be very helpful to us next year when our fathers are planting corn. We should get them to plant seed secured only from stalks that produce the most corn, whether the stalk had 2 or more ears or only 1. If we follow this plan year by year, each acre of land will be made to produce more kernels and hence a larger crop of corn, and yet no more work will be required to raise the crop. In addition to enlarging the yield of corn, you can, by proper selection of the best and most productive plants in the field, grow a new variety of seed corn. To do this, you need only take the largest and best kernels from stalks bearing 2 ears, plant these, and at the next harvest again save the best kernels from stalks bearing the best ears. If you keep up this practice with great care for several years, you will get a vigorous, fruitful variety that will command a high price for seed. Experiment. Every schoolboy and girl can make this experiment at leisure. From your own field get 2 ears of corn, one from a stalk bearing only 1 ear, and the other from a stalk bearing 2 well-grown ears. Plant the grains from 1 ear in one plot, and the grains from the other in a plot of equal size. Use for both the same soil and the same fertilizer. Cultivate both plots in the same way. When the crop is ready to harvest, husk the corn, count the ears, and weigh the corn. Then write a short essay on your work and on the results, and get your teacher to correct the story for your home paper. Section 20. Weeds. Have you ever noticed that some weeds are killed by one particular method, but that this same method may entirely fail to kill other kinds of weeds? If we wish to free our fields of weeds with the greatest ease, we must know the nature of each kind of weed and then attack it in the way in which we can most readily destroy it. The ordinary pigweed differs from many other weeds in that it lives for only 1 year. When winter comes, it must die. Each plant, however, bears a great number of seeds. If we prevent the plant from bearing seed in the first year, there will not be many seeds to come up the next season. In fact, only those seeds that were too deeply buried in the soil to come up the previous spring will be left, and of these 2-year-old seeds many will not germinate. During the next season, some old seeds will produce plants, but the number will be very much diminished. If care be exercised to prevent the pigweed from seeding again, and the same watchfulness be continued for a few seasons, this weed will be almost entirely driven from our fields. A plant like the pigweed, which lives only 1 year, is called an annual, and is one of the easiest weeds to destroy. Mustard, plantain, chess, dodder, cockle, crabgrass, and jimson weed are a few of our most disagreeable annual weeds. The best time to kill any weed is when it is very small. Therefore, the ground in early spring should be constantly stirred in order to kill the young weeds before they grow to be strong and hardy. The wild carrot differs from an annual in this way. It lives throughout one whole year without producing seeds. During its first year, it accumulates a quantity of nourishment in the root, then rests in the winter. Throughout the following summer, it uses this nourishment rapidly to produce its flowers and seeds. Then the plant dies. Plants that live through 2 seasons in this way are called biennials. Weeds of this kind may be destroyed by cutting the roots below the leaves with a grubbing hoe or spud. A spud may be described as a chisel on a long handle. If biennials are not cut low enough, they will branch out anew and make many seeds. Among the most common biennials are the thistle, moth mullein, wild carrot, wild parsnip, and burdock. A third group of weeds consists of those that live for more than 2 years. These weeds are usually most difficult to kill. They propagate by means of running rootstocks as well as by seeds. Plants that live more than 2 seasons are known as perennials and include, for example, many grasses, dock, Canada thistle, poison ivy, passion flower, horse nettle, etc. There are many methods of destroying perennial weeds. They may be dug entirely out and removed. Sometimes in small areas they may be killed by crude sulfuric acid, or may be starved by covering them with boards or a straw stack, or in some other convenient way. A method that is very effective is to smother the weeds by a dense growth of some other plant. For example, cowpeas or buckwheat. Cowpeas are to be preferred, since they also enrich the soil by the nitrogen that the root tubercles gather. Weeds do injury in numerous ways. They shade the crop, steal its nourishment, and waste its moisture. Perhaps their only service is to make lazy people till their crops. Exercise. You should learn to know by name the 20 worst weeds of your vicinity and to recognize their seeds. If there are any weeds you are not able to recognize, send a sample of each to your state experiment station. Make a collection, properly labeled, of weeds and weed seeds for your school. Section 21. Seed purity and vitality. Seeds produce plants. The difference between a large and a small yield may depend upon the kind of plants we raise, and the kind of plant in turn is dependent upon the seeds that we sow. 2 things are important in the selection of seeds: purity and vitality. Seeds should be pure, that is, when sown they should produce no other plant than the one we wish them to raise. They should be able to grow. The ability of a seed to grow is termed its vitality. Good seeds should be nearly or quite pure and should possess high vitality. The vitality of seeds is expressed as a percent. For example, if 97 seeds out of 100 germinate or sprout, the vitality is said to be 97. The older the seed, the less is its vitality, except in a few rare instances in which seeds cannot germinate under 2 or 3 years. Cucumber seeds may show 90% vitality when they are 1 year old, 75% when 2 years old, and 70% when 3 years old, the percent of vitality diminishing with the increase of years. The average length of life of the seeds of cultivated plants is short. For example, the tomato lives 4 years, corn 2 years, the onion 2 years, the radish 5 years. The cucumber seed may retain life after 10 years, but the seeds of this plant, too, lose their vitality with an increase in years. It is important when buying seeds to test them for purity and vitality. Dealers who are not honest often sell old seeds, although they know that seeds decrease in value with age. Sometimes, however, to cloak dishonesty, they mix some new seeds with the old, or bleach the old and yellow seeds in order to make them resemble fresh ones. It is important, therefore, that all seeds bought of dealers should be thoroughly examined and tested, for if they do not grow, we not only pay for that which is useless, but we are also in great danger of producing so few plants in our fields that we shall not get full use of the land, and thus we may suffer a more serious loss than merely paying for a few dead seeds. It will therefore be both interesting and profitable to learn how to test the vitality of seeds. To test vitality, plant 100 seeds in a pot of earth or in damp sand, or place them between moist pieces of flannel, and take care to keep them moist and warm. Count those that germinate, and thus determine the percentage of vitality. Germinating between flannel is much quicker than planting in earth. Care should be used to keep mice away from germinating seeds. Sometimes the appearance of a package will show whether the seed has been kept in stock a long time. It is, however, much more difficult to find out whether seeds are pure. You can, of course, easily distinguish seeds that differ much from those you wish to plant, but often certain weed seeds are so nearly like certain crop seeds as not to be easily recognized by the eye. Thus, the dodder or love vine, which so often ruins the clover crop, has seeds closely resembling clover seeds. The chess or cheat has seeds so nearly like oats that only a close observer can tell them apart. However, if you watch the seeds that you buy and study the appearance of crop seeds, you may become expert in recognizing those that have no place in your planting. One case is reported in which a seed dealer intentionally allowed an impurity of 30% to remain in the crop seeds, and this impurity was mainly of weed seeds. There were 450,000 of one kind and 228,000 of another in each pound of seed. Think of planting weeds at that rate. Sometimes 3/4 of the seeds you buy are weed seeds. In purchasing seeds, the only safe plan is to buy of dealers whose reputation can be relied upon. It not seldom happens that seeds, like corn, are stored in open cribs or barns before the moisture is entirely dried out of the seeds. Such seeds are liable to be frozen during a severe winter, and of course, if this happens, they will not sprout the following spring. The only way to tell whether such seeds have been killed is to test samples of them for vitality. Testing is easy, replanting is costly, and often results in a short crop. Exercise. Examine seeds for both vitality and purity. Write for farmers' bulletins on both these subjects. What would be the loss to a farmer who planted a 10-acre clover field with seeds that were 80% bad? Can you recognize the seeds of the principal cultivated plants? Germinate some beet seeds. What percent comes up? Can you explain? Collect for your school as many kinds of wild and cultivated seeds as you can. End of Chapter 3, Part 2.